Well, we are about to begin a new unit, Systems of Equations. But what you're going to notice is we're going to use what we learned last chapter to do this first portion. Okay, so a system of equation. Basically, a system is where you have more than one. And when you have more than one equation, you're going to have different scenarios occur. So here on this first example, we've got a system of equations. You can see that there's two graphs. And look at the two graphs. How many times do they intersect? You can see they intersect once. So this is when you would have one solution. Now I'm getting used to my new pen here. Haven't used this in a while. It's a little too thin, don't you think? Let me make it thicker. Okay, there we go. Now, when we look at this example here, we've got a set of parallel lines. And what do you know about parallel lines? Well, you know that their slope is the same, right? Well, how many times do these two equations intersect? Well, they don't intersect at all, Ms. Kleiber. So therefore, this system of equations has no solution. There we go. Now you should be taking notes on your paper also. I'm having troubles. There we go. Now we've got our third type of example. Now this example, it appears that this is not a system of equations. It appears that there's just one equation. But what you can't see is that actually there are two equations and they're the exact same equation. So how many times do they intersect? Well, Ms. Kleiber, they intersect all the time. That's right. So that means that there is infinite solutions. That means any ordered pair that works for one equation will work for the other equation. So these are our three scenarios that will happen when we solve systems of equations. Now, first of all, what we're going to do is I'm going to show you how to check a solution. So let's say you get the ordered pair 8, 1 makes this system of equations true. That means if I were to graph these two lines, they would cross at the ordered pair 8, 1. So what I do to check the solution is I substitute the 8 for x and the 1 for y, and it should make both of them true. So let's check it out. So the first equation, does 8 plus 1 equal 9? Well, yes, we get 9 equals 9. So therefore, 8, 1 makes the first system true. Now let's check the first equation. Now let's check the second equation. So we have 2 times x, but we're not going to use x. We're going to use the value 8 minus 5 times y, but we're not going to use y. We're going to use the value 1 is equal to 11. So we end up with 16 minus 5 equals 11. And yes, that is true. 11 equals 11. So therefore, we have just proved that this system of equations is true with the equation, with the ordered pair 8, 1. But now let's try one more. So let's say now on our second example, we have the ordered pair 2, 0, and we believe it is a solution to the system given here. So let's check it out. So the first equation is y equals x minus 2. So y is 0 and x is 2. So does 0 equal 2 minus 2? Well, yes, of course it does. So 2, 0 makes the first equation true. Now let's check it out with the second equation. So we have y, which is 0, is equal to negative 3 times x, which is 2, plus 4. So we have 0 equals negative 6 plus 4. Well, what's negative 6 plus 4? That is negative 2. So does 0 equal negative 2? No, it does not. So therefore, 2, 0 is not a solution to this system of equations. And that's how you check a solution. Now let's go ahead and find some solutions. So, whoops, I need to switch to my finger mode. And let's move this slide up. Oh, actually, I need to go to the next slide. Here we go. Here's the table. Now we are going to solve this system equation. Now the system is labeled, and then I have a second equation labeled g of x. And we want to know what is the solution to this system of equations. Now we're going to use a numerical approach. So what we're going to do is we're going to substitute the value 1 into f of x and find the values. So 1 minus 3 is negative 2. 2 minus 3 is negative 1. Sorry, my negative doesn't look great there. There you go. 3 minus 3 is 0. This pen doesn't write so well, you guys. You got to bear with me. 4 minus 3 equals 1. and then 5 minus 3 equals 2. Okay, now let's look at the ordered pairs, and this is a 0 here, it looks like a 6. There we go. So now let's do the ordered pair for the g function. Now we have negative 2 times 1 plus 9. So negative 2 plus 9 is negative 7. And then we have negative 2. I'm having issues. There we go. Times 2 plus 9. So negative 4 plus 9 is 5. Wait, that isn't negative 7. It's supposed to be positive 7, huh? I knew you caught that. Man, I think I need an eye pen to do this. So negative 2 times 3 plus 9. So negative 6 plus 9 is 3. And then negative 2 times 4 plus 9. You get the hang of it, don't you? Negative 8 plus 9 is 1. And you should see a pattern on the right, correct? Negative 2 times 5 plus 9 is negative 1. Do you notice the pattern here on the right? Because you guys know all about slope now, right? And so you can see that it's decreasing by 2 each time. And that's because the slope is 2. Okay, now let's look at the tables. And we are looking for an ordered pair that is the same on both of the tables. Now here I have 1, negative 2, 1, 7. That is not the same. Here I have 2, negative 1, 2, 5. Not the same. 3, 0, 3, 3. Not the same. 4, 1, 4, 1. Woo-hoo! We have a solution. The solution to this system of equations is the ordered pair 4, 1. So if I were to check it for the f of x function, what is 4 minus 3? Well, it is 1. Yes. And for the g of x function, what is negative 2 times 4 plus 9? Well, it's 8. Negative 8 plus 9, which is 1. Yes, we did it. Next slide. I thought I had a table somewhere. Don't you guys see a table on yours? I do. Okay, now the graphs. Now let me move my page up a little bit here. Here we go. Now we are going to solve this equation using a graphical approach. So we just did the numerical approach, and now we're going to do the graphical approach. Well, we know how to graph these two lines. In fact, the first line has a slope of 3 and has a y-intercept of 0, negative 4. Now make sure you always write the y-intercept as an ordered pair because it's a point. Now the second equation has a slope of negative 1/2 and then has a y. 0, negative 4 would be right here. And then my slope is 3. So I'm going to go up 3 over 1. Up 3 over 1. Up 3 over 1. Do you see a line forming? I do. Now I'm going to draw a line. Now you'll have to forgive me because I can't use a ruler on my iPad here, but you should be using a ruler. Yikes, that's awful. Okay, now let's go ahead and, I can't even draw an arrow, there we go. Let us graph the other equation and let's see what the solution is. Now the other equation has a y-intercept of 3, 0, 3. And I'm going to go down 1 over 2. Oh look, we already found the solution. We can see where they cross. They intersect at one point. So that means that this system of equations has one solution. Okay, and the solution is 2, 2. Now remember, you can always check it. So you go back to the original equation and you go, does 2 equal 3 times 2 minus 4? So I'm using the first equation, and yes, 2 is equal to 6 minus 4. Now check the second equation. So does 2 equal negative 1/2 times 2 plus 3? And negative half of negative 2 is negative 1. So yes, 2 equals 2. We found the solution using the graphical approach. Now we're just going to do one more example here. Okay, now these equations are not quite as easy to graph. Do you notice that? And it's because of how they're written. Now they are written in what's called the standard form because you have your two variables equal to a constant. Two variables equal to a constant. So in order for us to graph them, we could either make an XY table or we could solve for Y and get slope-intercept form, which is what I'm going to do. So I'm going to have negative 3Y is equal to negative 2x plus 12. That's a 3. So now I must divide every single part by negative 3. Now remember, always on equations you have to divide every single part because it's the division property of equality. So now I have y equals, and a negative divided by negative is a positive. So I have 2, please write for me, thirds x, and it's minus 4. Okay, so we can see there that my slope is 2/3 and my y-intercept is 0, negative 4. Fantastic. Let's graph that line. 0, negative 4. And I'm going to go up 2 over 3. Up 2 over 3. Up 2 over 3. Okay, I know. Enough. So now using your ruler, now I can't because I'm on an iPad, draw your line. Okay, now let's graph the second line. I'm going to use a different color. Let's use blue. So now I'm going to get y by itself. So I'm going to divide every